No, we've been looking forward to doing this, and also looking forward to Darren showing Randall his new tool that he's got out on the interwebs right now. And yeah, we've got the Chelan trip coming up too, Darren, in October. But this one is next, the Finger Lakes in New York. Was it technically New York?
Finger Lakes is technically New York, and yeah, just New York. What can I say? And in fact, it was part of New York probably before any serious technology even existed. Western New York, yeah, really a very different place than along the coast.
All right, and it's August 30th to September 5th, 2026, of course.
We're flying into the falls, right? Into Buffalo, Niagara, so we'll get to see the U.S. side of the falls. I've been to the Canadian side, but I've never been to the U.S. side before.
Well, the big advantage to the U.S. side is that you can actually get a better perspective on the Canadian falls.
Ah.
Because you're not quite jammed up against them.
Right, exactly. But that's worth seeing because it gives you at least some framework for thinking about, like, if you're standing near dry falls. And then you realize that it's 2.5 times, almost 3 times the height of Niagara. And the volume, let's see, what is the volume of Niagara? It's pretty impressive, but it really does give one a sense of the power and majesty of these giant floods. And of course, it is a relic of the Ice Age and the deglaciation of the whole region up there. So I opened the national map viewer here, and yeah. So are we going to start with? I get to see what you've been working on there, Darren, or you're going to keep me in suspense?
Oh, do you want to see that first?
Oh, I don't know. You brought it up. I didn't know when you were going to, like, first, middle, or later. Last.
I was going to do it later, but I could do it now. I got it right here, ready to go. I think I can just share my screen. This is my new disaster map.
Oh,
disastermap.ca.
Yeah. Okay. I saw you sent me that. I haven't had a chance to dive into it yet.
Yeah, that's good. So then it can be a surprise. So basically what I've done here, and I mean, you were the inspiration for a lot of this. So I can do different things. Like I can click here. I can set this. The first feature is I can set the ocean level to wherever I want. So we could melt.
Oh, wow.
We can set whatever, we can manually set whatever we want, or we got some presets here, like just melt all the ice on the planet melted. And it'll give you what your new coastlines will look like.
Oh, okay. Let me see if I'm going to, let's see.
Yeah, you're okay up there in Atlanta. Yeah, you're right. Yeah.
You're okay up there.
Oh, yeah. Okay, I am. Well, it'll be better, really, in a way, because it'll probably take an hour off the commute time when I go to the beach.
Yeah, exactly. And then if you click there, it'll give you how much the new elevation is, what you'd be underwater by.
Now, okay, and then you drop the ocean level.
Now,
right?
Yeah, now I can drop the ocean level, which is interesting, probably more interesting for this crowd, because now you can start to look at where the ancient coastlines used to be.
So this is pre-Younger Dryas, like pre-Younger Dryas?
Yes, this would have been pre-Meltwater Pulse 1A.
Yeah, exactly. Now, the interesting thing about that is, I mean, obviously that doesn't give us the isostatic rebound in the Azores yet, because I haven't built that in yet, but you can start to go look at things like the Bering Sea here kind of completely disappears. So, I mean,
Bering Strait, yeah.
The Bering Strait. What Graham and I used to talk about is you didn't even need people. I mean, obviously we think there was people here that got pushed out by the cataclysm and then probably just came back north as things chilled out. But you can sort of see where you would have just had this coastline you could have sailed around the whole time that would have brought you all the way down to California.
Oh, that's an interesting way to look at it too.
And check out the arc of the Aleutians there. I mean, if you're sailing up the north along the east coast of Asia there, you cut along those islands.
Right,
yeah, I mean, look at this.
Oh, that's really interesting.
Now, let me come across there and across here.
Did you, how much did you drop sea level? 400 feet?
So that is
120 meters.
393 feet.
Okay, close enough.
Yeah, we could do 400 though. We just type it in, hit execute.
Now, really, it's surprising. I remember the first time I looked at long time ago, looked at a reconstruction of Beringia, which is the area up there in the Bering Straits between Alaska and Siberia. You don't realize how much land you're actually talking about. You think, the land bridge, and you think, well, you see those two prominences right there in the middle.
Yeah, that's like 4 times the size of Alaska there.
It's enormous, and that whole area was populated with millions of megafauna.
Well, keep going to the Baltic Sea there too, Darren. Go left. Right there. So there's look at Doggerland and the Baltic Sea even. Like Scandinavia is basically there's no ocean there, either sea there.
Right. And you see that blue arc of ocean that comes around the southern end of Norway there?
Yeah.
That is a huge scoured catastrophic flood trough. And you can see, if you see that there's that valley there between Norway on the west and Sweden on the right. And of course the ice sheet, the Fennoscandian ice sheet, covered all of that up there. And when it was melting, at some stage, probably at a latter stage, you had a huge meltwater river coming down that trough between Sweden and Norway, and then it arced around. I'm not sure why it did that, but you can see there's actually a deep trough that follows the arc there of the southern coastline of Norway. And then it discharges into the North Atlantic up there by it's called the Norwegian Sea.
It surprises me, the Mediterranean, how much is still there. I thought we would have seen more land.
You know what else is surprising is if you add a bunch of water to it. Even if you had 200 feet of water, the Mediterranean really doesn't get much bigger.
Uh-huh.
Yeah, that's interesting.
But the other thing you might like about this, Randall, is it's got all the asteroid mechanics built into it, so I can switch into impact mode, pick some place to do an impact.
Well, go near the Finger Lakes. Like let's look at that place we're going here.
Where's that?
I'll tell you exactly where to go. Zoom in on Lake Ontario.
Oh, there they are, right?
Now, there's the Finger Lakes, and then north of there, between Lake Ontario and the Finger Lakes, are the drumlin fields. But zoom in on eastern Lake Ontario.
Eastern Lake Ontario over here?
Well, not quite that far east. Is there a cursor? Do you have I'm looking for
a cursor. I don't think you can see it, though, for some reason. Right now, my cursor's right on Oswego.
Okay, you see the dashed line, boundary line? Okay, so come down and follow that to the west until I tell you to stop. Get the boundary line back down around the center of the screen. Right about there. Now kind of go to the west, and where it says Lake Ontario, center that. Put that on your center. That's pretty damn close to where the impact would have been, right there.
So now this could be weird because I haven't run an impact in a lake yet, but let's see what happens. Man, it's got weird on me.
Well,
but if you do it over here, what it'll do
it at Rochester there and see.
It'll give you can pick your asteroid size. It'll give you your crater size, your ejector radius, your blast radius.
So what is the radius of the impactor for that?
That's at 1 kilometer.
Is that the radius or the diameter?
That's the diameter.
Okay, so half a kilometer.
And then it made a crater 35 kilometers. Is that right?
Okay. Now, having made that, can you drag that up over that basin of Lake Ontario?
Oh, that's interesting. Yeah.
Now that it's made?
No, I can't. I have to remake it. But what I could do is maybe cheat it right to here and run it from there.
Well, I was trying to look at the radius of destruction compared to the geomorphic work, because it likely at the point where the flood occurred, the southern margin of the Ontario lobe of the Laurentide ice sheet would have been right at the top end of the Finger Lakes.
Oh, right, wow. Here.
So the drumlins would have been under the Finger Lakes, and normally, you would find a huge terminal mooring at the terminus of the ice sheet of the glaciers. You don't really find that here. But what you do find is what's called the Valley Heads moraine, which is all of the moraine material that got washed down to the south end of the Finger Lakes.
So before I wrap this up, Randall, I'll just show you a couple more features. I got things so you can, I got the wave engine built in. So if we put a rock into the middle of the Gulf of Mexico here, it'll kind of give you your flood inundation and your wave parameters.
Oh, okay.
And then I got
wave height too, eh?
wave height. Yeah.
Now, you mean based upon an impact?
That'd be based on a 1,200 meter diameter asteroid hitting the Gulf of Mexico.
Got it. Okay.
Perpendicular, like not on an angle, right? No
45
glancing
degree
blows,
angle.
right?
It's all built off 45-degree angle impact.
Yeah.
So that kind of shows us a wave height of 85 meters just from a 1,200 meter rock.
Right. By the time, this is when it's making landfall.
No,
Yeah. This would be on impact when it hit the ocean. Oh yeah, so that's the wave would be 85 meters when it hit the land if it landed in the center of the Gulf.
Yeah. And
I
I
can
can
the other
see.
thing you might get a kick out of is we got the Yellowstone mode that'll show you the ash radiuses and depths for each of the 3 Yellowstone eruptions.
So I'm pretty cool in that department also, aren't I?
You look okay. It looks like where you are, where's Atlanta now?
No, you're just on the edge there. Yeah, right there. Yeah.
You got an 85 to 95% survival odds.
Okay.
1 centimeter of ash only. So a half-inch ash.
Okay.
And now this one I'm still working on, but I think this is the one you get the biggest kick out of. I haven't got the flood tiles built into it yet. But I have this mega tsunami mode where we can pick La Palma, Cumbre Vieja, Cascadia, or Alaska, and it'll show us sort of the fallout from that landslide. And if I click here, it'll give you the wave arrival times and the estimated wave height based on worst case scenario. So this one here takes 9 hours and it hits the coast at 15 meters, so 50 feet tall still.
50 feet, what?
50, so it says that if Cumbre Vieja, if they talk about the Canary Islands slipping away and doing a landslide, making a mega tsunami.
Right. So that's okay. Yeah, got it. So this is epicenter on one of the Canaries.
Cumbre Vieja,
and this is showing the effects of a large landslide.
Yeah, into the ocean.
Into the ocean from off of the island.
Exactly.
Right, got it. Okay. And then that's the wave height going out. What's it doing by the time, let's say, it gets to the east coast of the United States?
So if right outside of the say at Charleston, it's still going to be 50 feet tall, and it's going to take 9 hours to get there. It says extremely dangerous evacuation essential. So if we go right to Atlanta, yeah, it says you better get out of there if that happens. But you'll have 9 hours. So
wait. What now? Well, Atlanta, we're at 1,100 feet above sea level.
So this is the thing that I haven't built in yet. I haven't built in this last mode. The mega tsunami mode is not built into the bathymetric data yet, so it's not being affected. So the asteroid into the Gulf of Mexico, I built that into all the elevation data so that the wave stops based on the elevation of the land it's hitting. And now what I'll do next is build that into this mega tsunami mode too. So because at 1,100 feet, you'll probably be okay. And it'll sort of show that same wash in, how it'll wash into the land.
It would probably wash up the Savannah River Valley and the PD River.
Get a kick out of that. Yeah, exactly. It shows that. So if you do the impact into the Gulf, it shows it really going up that river valley for a couple hundred miles.
Up the Mississippi. Well, first thing I want to call your attention to is the Finger Lakes themselves. And what you'll notice is if you draw a line along the long axis of the Finger Lakes, they actually converge. They're radially distributed. That's important point number one. And if we go here to where these lines would meet, right there. That's where I had you go to when we were trying to drop the asteroid into the basin of Lake Ontario. Would have been right in here. And we can actually see that the deepest part of the lake is this area right here. And there's some very interesting scablands on the floor of Lake Ontario down here. And I think I can...
You can see it if you change to the layer. It'll show it on the layers. Yeah.
Yep.
I'm playing with my elevation cursor here, and it looks like it's about 500 feet deep at that one spot.
Yeah, here you go. Look at this. So this right here, this is the area. This is the basin. And I would theorize or hypothesize that this is essentially the impact point. And you would have had you would have water rushing in both directions, to the northeast and to the southwest, and probably this all drained off ultimately to the north. And let's see if we can actually see this. Yeah, look at this. You can see these scoured features here. Look at this right here. See all of this? So all of this is showing that there was these huge flows, probably in both directions. I would say the first flow out, let's see if we go back to the terrain view.
Well, it would naturally follow those river valleys, right?
Would naturally follow the river valleys. And it passed up. In fact, we can trace the flood. It passed right up here this way. It created a big temporary lake right here where Montreal is.
Which is now a nice delta.
Yeah. And then it would have continued on out right up here and out this way into the North Atlantic. And all along here, we find some very interesting things, like Lake St. Jean right here is highly suspicious. And there's a good reason to believe why that may have been an impact site right here. And there was a catastrophic draining out here past Saguenay, if that's how you say it, out here. And you can trace the pathway of catastrophic current flows right down through here and out. And they emanated from what is now a basin occupied by Lake St. Jean. And there is microscopic evidence all the way down to Pennsylvania and New Jersey that is of a petrology that's only consistent with the bedrock right up here in this region right here.
So you can almost see like an impact circle there, but that would have been, so how much ice would have been there?
Right there, it would have been about a mile thick.
A mile thick?
Yeah. Well, it depends. I mean, at its maximum, the ice there was about a mile thick. So and it was probably a mile thick down to the least meltwater pulse 1A, so 14,600. It was probably still close to that at the lower Younger Dryas boundary. What we need, we just don't have enough. We don't have enough chronological data to reconstruct. Because see, like in my mind, okay, what is the exact correlation in time between these huge floods coming out this way and the floods that we were exploring over in eastern Washington? My gut tells me they were probably simultaneous, but I don't know because the dating is still too broad. Now, if you look here, look at either one, Cayuga or Seneca Lake here. And you see about how long they are. We can actually, let's measure the distance, and we'll go up here to Geneva, and then we'll go to the south end of the lake at Watson Glen, about 20 miles. Okay, we're about 20 miles, okay? So now check this out. I'm going to clear. I want to clear this out.
Oh, you're in print mode now. You have to cancel that in the top right.
How did I get in print mode? Well, no, now I'm in print mode. Let's see, cancel.
You got to cancel down at the bottom of that first.
Oh, there we go. Okay, thank you.
And then probably cancel again up in the top.
Right next to print. Yeah, the gray cancel, right?
Yeah, there we go. But there should be a clear yeah, there's, oh, maybe it's being, let's see this. Yeah. So, you see, it was hiding behind the stop sharing button. That's why I couldn't find it. Okay, so what did we say? 20 miles. Okay, so now I'm going to zoom out, and we're going to go over here to Washington. We'll come in right here to Grand Coulee, and let's just right-click, and we'll do measure again the distance. We got, what is that? That's 10 miles.
21 miles.
Oh, yeah. 20. So maybe you get my point. They're both the consequence of catastrophic flood flows. In the Scablands, we're eroding into basalt bedrock, and in the Finger Lakes, it's shale bedrock. And so it eroded differently. And in the aftermath of these floods, the post-flood environment has been very different, because it's the difference between, 15 inches of rainfall annually out by Grand Coulee, and I think maybe in the order of at least 50 inches in western New York. So it's a very, very different environment. But basically, I think we're looking at the same type of feature that had the very same type of origin, which was catastrophic flows. Clear, that's what I was looking for last time. Okay. So I think you can see the similarity.
So would those all been like little rivers at one point then? Those would all been the heads of rivers?
What, these lakes?
Yeah.
Well, see what's happening?
They would have all been under the water.
Okay, so you had the glaciers coming down here. Imagine you're drawing a glacier margin along the north end of these lakes. And then you, because there's a glacier margin here, there's going to be massive amounts of terminal mooring. The problem is, though, is when the water came down and flushed through here, all of the mooring ended up getting deposited down here at the south end of these lakes. So there's huge amounts, they call it the valley heads mooring, and it would have been washed down here by these floods. But see, another difference here is that you see here the floods are going up gradient. You see, we're going uphill into the Allegheny Mountains here. Whereas the coulees out at the Channeled Scablands, the whole Columbia Basin is tilting to the southwest. So it's not really running into this,
this hill, yeah.
So then that would have just washed back into Lake Ontario eventually?
Yes. But you can see here when you zoom in, all of this is water cover. So this is beyond the glaciers. See, this is the water channel. This is water doing this. And then you've got your flat, because the final drainage of all of this would have been a relatively slow affair, and that's where it would have built the alluvial bottom of the modern river valley, or creek valley, whatever this is. I don't know what that is. Catherine, is that what it is?
Catherine Creek.
Catherine Creek, right. So Catherine Creek there's probably a lot of glacial moraine in here, and when this flood came down, it would have washed all of this stuff back up here, like all the way up. You can see the effects of the backwash are still in here. And then when the water finally reversed and drained off, it's lost all of its energy in the onrush that's moved it uphill. And then it reverses in here, and somewhere right in here, if we went down and looked, we could probably find in a road cut or a railroad cut or in a stream cut somewhere where the actual reversal took place. But you'd be able to see the water rushing up this way, going to the south, it's going uphill. And then it reaches the highest elevation that the backwash carries it, and then it'll stop for a while until the water to the north drains off. Then this will drain back out, but the draining out is a much, much lower energy event than the wash in, see? So then all the wash in of it carries all this sediment, and then to drain back out to the north, leaves the sediment behind and builds this flat valley floor that the modern creek is now flowing on. But this, like all this right here, see, is a continuation of the channel that created the lake. See? So you had this water rushing down, and then it split. It looks like we got some water going this way. Let's see. The main flow seems to have gone down here, but it looks like all of this area in here is water eroded. So for a little while, all of these valleys were probably submerged. Not all the way to necessarily the top of the hills here, but all of this would have been water. Like this was probably a pool of water right in here. And you would have had, let's see, this, yeah, look at this. See, here you had this coming off of Cayuga here. And we go down here, and yeah, so it was flowing and backwashing all the way down here. So this whole landscape, you can see, has been incised by these huge current flows that in many cases, like this right here, you can see it essentially cuts right across at right angles to the pre-existing drainage, see? The hills are oriented northeast, southwest. The drainage, the original drainage is pretty much oriented northeast, southwest, but this flow comes in and it just slices across and completely overwhelmed the pre-existing drainage. And then when it all finally flowed back out, it left a completely altered landscape.
Would the water have been sheet flooding over all of that? Because it kind of all looks torn up.
Well, it could have been. Yeah, at one point it could have been. It was definitely sheet flooding to the north of the lakes because, remember, drumlins only form under the ice. Remember? Got that? Drumlins only form under the ice. Why is that? Well, because for the water to sculpt the ground mass, the pulverized till under the glaciers, which can be dozens to hundreds of feet thick, that water has to be under pressure. And it's the special properties of the aerodynamic properties, actually fluviodynamical properties of the subglacial water flows when they're under pressure. Put those water flows under pressure, and now what they do is they start shaping, and especially, remember, under the glaciers, you've got this pulverized till, which forms the moraine. You know, the terminal moraine, the lateral moraine, the recessional moraine, all the different manifestations of moraine, but they're all composed of glacial till. Till is the stuff that the glaciers produces when it comes in there and grinds over the landscape, pulverizing the landscape. So this till forms thick layers beneath the ice sheet. Now, push a high-pressure subglacial flood through there, right? What that flood does now is it does two things. It starts eroding upward into the bottom of the glacier, and it starts eroding downward into the thick layers of glacial till. And interestingly, the pattern you see in the ceiling of this now subglacial tunnel with all of this gushing water current catastrophically flowing through it, what you see on the ceiling almost mimics what you're seeing on the floor. And on the floor, what it's doing is it's taking this glacial till and it's sculpting it into these aerodynamic shapes. So think about a boat hull. When you're in a boat hull is designed to minimize the frictional drag on the hull of the boat as that boat is moving through the water. Well, the reverse of that is if water is flowing against an obstruction or an obstacle, depending on how cohesive the material is, if it's not very cohesive, that water is going to immediately start shaping it. And what does it do? It's trying to minimize the frictional drag, the shear forces that occur between the movement of the water against the obstruction. So what it does is it tries to shape any obstruction to its flow into a geometry that will provide the least resistance to the flow, which is going to be this aerodynamic shaping. So when that happens, but once the water issues beyond the edge of the glacier, it's got a free surface, so it can adjust its depth to whatever it needs to be to try to reach equilibrium with the atmosphere, which it's not allowed to do when it's under the glacier. So what happened here is that the water is gushing subglacially under the ice sheet, whose terminus was the north ends of the lakes, and when that subglacial water under really intense pressure discharges from out of that ice sheet, it now has a free surface but it's rushing out and forms these channels here, backwashing up into the Alleghenies until it reaches some, I don't know yet at what elevation above sea level, but then at some point, water will then reverse flow, and it'll flow back out into the Lake Ontario, and then it'll flow northeast right up through the St. Lawrence Seaway and ultimately flow back out to the North Atlantic. So if I zoom out here now, you're going to see here's the north end. Now picture the ice sheet is right down here. Now we're going to go up under. We're going to go into the dome.
I was picturing, you know where I was picturing it? The number 90. If you look at the other layer, but it looks like that 90 kind of traverses the bottom, like the moraine, the terminal moraine.
I'm not seeing what are you looking at?
If you go to the other layer just for a sec, and then we'll get back to what you're going to show us with this one. But go to the other layer.
The satellite view.
Yeah. So I almost, and if you zoom out a little bit.
Oh, Interstate 90.
Yeah, 90. If you zoom out a little bit,
okay,
just a little bit, it looks like you can see the terminal moraine underneath 90, like around where 90 is. Kind of like how in the Scablands you see that real obvious one, but this one doesn't seem so obvious.
Well, yeah. So it might show up pretty. I don't have Google Earth open, but it probably shows up better in Google Earth.
Yeah, maybe. Yeah.
Especially if you go to 3D exaggeration, which Google will let you do. You can go double or triple or whatever. I usually just go double, but what that does is helps you visualize differentiation within the terrain itself, within the topography.
Yeah.
But so basically you'll notice again, look at the radial pattern. If I go back now to the digital and you go up to the drumlin swarms, notice the orientation here. So the eastern drumlins are oriented to the northwest. See that?
Yep.
Okay, now as I come over here, we see that they're now oriented almost north-south. And then if I keep going, they're oriented.
Wow.
Yeah. And if you follow that trajectory, the convergence point just so happens to be the same convergence point as the lakes.
Which just so happens to be the deepest part of Lake
Which
Ontario.
just so happens to be the deepest part of the lake, which just so happens to have this really weird pattern of erosion that almost looks like drumlin-like, but long, skinny. I mean, look at that. This is definitely...
Is that just from like the material, the ice and everything getting sort of hammered into the ground?
I think that this is, if this was the unimpact site,
because
like, look here.
Compressing all that ice, dramming it into the ground, right?
Yeah. Oh, yeah. And you would have... Well, okay, so the bolide hits, it fractures the ice instantly, but then it does two other things. It melts a whole lot of water, and of course the greatest, and this will be fun to use your new toy with, because you have it programmed so it gives you the temperatures at the point of impact.
I don't know if it does, but I can find out.
That would be a cool thing to know.
If it doesn't, I can add it easy enough.
Because then from that we could calculate how much, like at what radius would the ice be vaporized? What radius would it be liquidized? What radius would the radial fracture patterns extend outwards? See, that would be really great stuff to know, because then we can reconstruct an event like this. And
well, what's the material underneath that lake? That looks like almost creases, like something's been smushed up. Like if the impact happened, is there a chance that it would just smush that bottom of the lake up like that? Like
no. I think what we're seeing here is that there's probably thick layers of glacial material sediment on the floor of the lake.
Okay.
And this is showing us a direction of water flow. So I'm looking here.
Yeah, it's just weird because it seems to go down, like that.
I got some studies to do here as far as elevations, but look at this. You've got this terracing almost, you see in here. And then I'm thinking that maybe the impact would have been right here.
It kind of looks like it right there.
Yeah, and then you would have had this huge rush of water to the southwest because you're still under ice, right? Except that the ice has been fractured. And then you would have water flowing out. And, right, so like take this Finger Lake and draw the line up. And boom, you're right here.
Because there's got to be, I wonder if I can find a data set there's got to be calculations on what sort of impacts due to ice somewhere. I got to be able to find that somewhere. Because what I could do for you is add in the ice sheet layer first, and then I'll add in temperatures to each of those rings.
Yeah,
Because I'm just pulling that from like all the theoretical numbers that the scientists have agreed on. You know, I'm just downloading their data sets and then uploading them.
Yeah.
So if you could point me in the direction of the data sets that you're interested in and what you want to see, I'm pretty sure I could make it all happen for you.
Okay. There's not much. There's a few things, but there's not much. I've looked, and I've looked again.
The temperature variance is just going to be the size of the asteroid? Is that what it's only going to be related to size and angle of impact, or?
Well, it's going to be the primary parameters are going to be size, velocity of impact, and composition of the impactor. And to a lesser extent, the angle of approach obviously is going to be important. But I think the most important thing, because you might have an impactor can range from less than a gram per cubic centimeter up to 4 or 5 grams per cubic. An iron asteroid compared to a piece of a comet nucleus, that's a huge difference.
Yeah, what I set them with this one is I just sort of went, I had it take the most average asteroid compositions that we know about.
Right. And that's appropriate and suitable for what you're doing with it.
So speed makes a big difference too, because I could maybe look at adding that in there.
Yeah, velocity definitely makes it. Yeah, obviously the faster it goes, the more kinetic punch it's going to have.
Is there a point at which it becomes like
standardized?
Yeah.
Becomes what?
I'd like where just a speed where, like, you know, if it goes faster, it doesn't matter anymore. Is there like a terminal velocity?
No, I think no, there's not. As long as it keeps going faster, it's going to keep having more potential energy the faster it goes. And that whenever it encounters something, that potential energy is going to be instantly released.
Because I was thinking there'd be something that opposite of terminal velocity, but something where the atmosphere slows it down to a certain point where they all come to a certain slower rate of speed.
Well, that does happen. Absolutely, that happens. That depends on the size, pretty much, more than anything. I mean, the density, of course, too. I mean, because an iron asteroid that's 100 feet in diameter is going to hit the ground.
Faster. Yeah.
An object like Tunguska that's 100 feet in diameter, it hits the atmosphere and it does an airburst. You know,
but which is probably shittier if you're in that airburst zone, but better for everybody else.
Well, the radius of destruction for an airburst is greater than the ground burst because the ground impact, the ground absorbs a lot of the energy. And then, of course, with the aerial detonation, there's nothing to absorb the energy except the atmosphere. And so the radius of destruction is greater.
But then you wouldn't have you wouldn't have as much stuff tossed up to block out the sun and stuff like that.
That's right. So the aftermath of it would be probably better.
So it's like, because Tunguska happened and half the planet didn't even know about it. Whereas if that shit hit the ground, I feel like everybody would have been pretty aware that something went down.
Here's a good comparison. Tunguska, actually, I think the closest estimate's about 150 feet in diameter, right? The iron asteroid that struck Arizona by Winslow and gouged out that crater, it was about the same size. The difference was iron asteroid and probably a piece of a comet. Could have been a piece of the comet Encke, which is part of the Torrid Stream, and Tunguska was
that, like, the immediate, like. So for Tunguska, everything in that blast zone is fucked. But if you're outside it, you might not be. Whereas that Phoenix one, it's a small crater. I think it's only a mile across or something like that. But would that have like blacked out all of Arizona for a little while? With how much particulate would that have tossed up into the air? And then how quickly does that sort of disperse, or does it hang out for a while?
Well, would that have been like I would, to try to answer that question, I would like compare it to the amount of particulate matter injected into the air in the wake of the eruption of Mount St. Helens. And it would probably be no more than that on that side, because the Arizona crater, about a kilometer across and 600 feet deep. So you could calculate the volume of material. And a lot of it is in the debris apron that spreads around the actual crater hole itself. But yeah, there would have been a lot of stuff thrown in the atmosphere, no doubt. And yeah, you would have probably been seeing that stuff hundreds and hundreds of miles away. And in fact, you could probably look at a radius of 20 to 30 miles. Anything within that radius probably didn't survive. The blast pressure would have been severe out to 20 or 30 miles from the point of impact, just like it was, at Tunguska. I mean, so there was about 200 square miles directly under the epicenter of the blast that were pretty much just incinerated. Not much there at all anymore. Then you get outside that zone, and that's where you have the old growth taiga forests that have been knocked down. About 80-some million trees. And it's all in a radius. You imagine you've got the forest. Let's see here. Okay, you've got the forest, all these trees there. The explosion occurs up in the atmosphere. That blast wave comes down along with the fireball, incinerates everything, but the blast wave then does this and then goes outward radially from that point, and that's where all the trees get blown down. And the radius of that destruction was about, it varies because it wasn't a circle, it was a butterfly pattern, but the radius of that right around between 15 and 25 miles from the epicenter, about total 800 square miles of forest blown down, and about 200 miles just incinerated. But yeah, a lot of the trees that got blown down, particularly closer to the epicenter, had scorched sides on them that would have been facing the epicenter.
Would the thermal radius so there would have been trees that were even still standing outside of the ones that were blowing out that got incinerated?
Yes, and in fact, the pressure wave, the blast wave coming down, there are actually a ring of trees that survived, but all of because they were directly parallel to the blast wave. And what the blast wave did was just sheared off all of their branches, so they're just naked single stalks, and that formed a ring. No. And then just outside that ring is where everything is splayed over. See?
I have a stupid question. Why does it detonate in the air? Like, what is actually causing it to not make it to the Earth? Is it on the angle? Is it on such an angle that it's going to miss the Earth, or is it?
No. Well, because air is a fluid. I mean, you ever done a belly flop?
Yeah.
Well, okay. So why did you have a belly flop? It was because the water wasn't getting out of the way in time, was it?
Right.
The water was not getting out of the way of your belly in time. Now imagine that your belly is a bolide.
Okay.
So now think of the difference when you take a beautiful dive in and you just you're right, you're basically parallel to the water column.
Yeah.
You slide right in. You come down with a belly flop. Boom! That water can't get out of the way. The air can't get. That thing is coming in at between 10 and 20 miles a second.
Okay.
Now you got 8 miles of atmosphere. So think of that. It's traversed the entire depth of the atmosphere, right, in a matter of a second or two. But what's happening is because the atmosphere can't even, think of it this way, the atmosphere can't get out of the way fast enough. So it just starts piling up. It starts compressing in front of it, right? And then it gets at some point where the atmospheric pressure gets how many G's? I don't know, but a lot. I mean, just like when you shoot a rocket off and those astronauts are sitting up there in that nose cone, they're subject to tremendous amounts of pressure. That pressure is a function of the velocity. In the case of an incoming projectile, that pressure is going to be a function of primarily the velocity, but then the point at which it finally, the atmospheric pressure, it's literally like hitting a brick wall. And in the simulations of an incoming bolide, when it does that, it compresses the atmosphere, and at some point, the pressure is greater than the molecular cohesion of the object. And it literally just sort of explodes by turning inside out.
So the type of the object would make a difference
you're
then,
already.
too,
Wait, what now?
Go ahead, Graham.
the type of the object, the type of the material would make a big difference in that.
Makes a big, huge difference. And that was the difference between an iron asteroid in Arizona hits the ground and digs a big hole.
And-
Tunguska, which is about the same size, it couldn't penetrate all the way through the atmosphere. Now, obviously, low density, it has to be bigger, but eventually you can get to a size that's big enough. Yeah, it's going to penetrate the atmosphere for sure. You know, a half a mile comet nucleus made out of ice is going to penetrate the atmosphere and hit the ground. Although it may fracture by the time it hits the ground. It may have begun disaggregating. You see what I mean? So, I mean, there's a lot we still got to learn yet about this, the cosmic environment and all of its denizens that we could potentially encounter. Because there's a wide variety of beasts out there, cosmic
so none
beasts.
Of those trees are squished flat before the blast, even because you got to think if the pressure between, if it can compress the atmosphere enough to make enough pressure to blow up a giant rock, that the amount of pressure that would be built up between, say, if I'm standing underneath it and the planet would have already squished me flat before it even blows.
Well, yeah, but again, the time frame is so short.
It's just like, yeah.
It's almost instantaneous, right?
But you never hear the bang.
So Tunguska is estimated 5 miles up in the atmosphere. If it's moving 15 miles per second, then it's a third of a second. It's going to have penetrated the whole atmosphere. I mean, that's how fast it, but of course it's not moving up because immediately as it's coming into the lower atmosphere, the density of the atmosphere is increasing naturally because, you know, what is it, 14 whatever pounds per square inch atmospheric pressure at sea level. Well, what do? When you get up 5 miles up, 8 to 8 miles up, I think it's pretty much zero. So you go from 0 to 14 point something miles, pounds per square inch. But what's happening is that the atmospheric pressure column is increasing as this object is coming in. But again, if it's moving at 15 miles per second or 10 miles per second, what does it take? It takes a half a second to penetrate the entire air column. So the whole thing happens so fast. I mean, that pressure builds up. It's almost instantaneous. You know, and so you might see the thing while it's farther out before it really descends into the lower atmosphere. But then if it's coming in at an angle, once it hits about 8 to 10. Well, remember Chelyabinsk over Siberia in February 2013? That exploded, I think it was around 15 or 16 miles up in the atmosphere. So it was probably not a very dense object. It was probably a low-density object similar to Tunguska. It was smaller. It was probably not. And also, if it's a rubble pile object, which can be asteroidal or cometary, instead of a single well-consolidated like rock, you might have a bundle of stuff that's gravitationally cohered together that's been traveling around in space together as an accreted clump. But once it starts penetrating the atmosphere, all those pieces come apart. And now what would have been maybe like a single, you know, rifle bullet now becomes like a shotgun.
Yeah.
Which is more dangerous?
Well, you certainly have a bigger target radius with the shotgun.
Because it's like my shotgun is dangerous, more dangerous, say, out to 50 yards. But after that, the rifle becomes more dangerous.
Uh-huh. Mm-hmm. Yeah, that makes sense.
So it's like that same sort of idea where you're better if the shotgun's better, the rifle or the shotgun's better if you're not right there.
Speaking of bolides, have you seen all these ones lately in the news, Randall? People are arguing over whether it's like from the leftover from 3I Atlas or the new meteor stream, what are they calling the Nereids or something? Or there's another one that people are arguing over. Have you seen them all online?
No, I certainly know that there have been a lot of bolides lately. And of course, that's
crazy amount.
Yeah, well, that's because I started talking about it again. I had,
but I don't know if it's just like all this stuff's going viral and they're showing us all of it now, or if it's actually increased in frequency as well. You know, it's hard to know what's what's really happening?
Well, I've been tracking it for a while now, and I've pretty much concluded that the delivery of this stuff into Earth-crossing orbits is definitely clustered.
Okay.
You have periods where it gets pretty sparse, and then you'll have a cluster of things, a short
Are we in a
bombardment.
cluster right now?
I would say yes. I would.
Is that a separate cluster from the like annual clusters we see, the torrid
Yes.
and the other one? It's
Yes.
like a bigger cycle outside of that cycle.
Yeah. So, let's see. What is today? Friday. So about Tuesday, I'm not going to read the whole thing. I'm just going to read you a little bit. I started writing something, and just gives a little background here. And this is what I wrote for publication in the next few days. Starting in the 1980s, after the 1980 publication of 3 independent scientific papers, all making the case that the extinction of the dinosaurs was the result of a hypervelocity impact of an asteroid or a comet approximately 66 million years ago, I embarked on a project to track present-day celestial activity in the near-Earth environment. As the years passed and our ability to discover and track objects moving through our cosmic neighborhood has improved, the realization has been growing that we are far more vulnerable than we had previously imagined to a disaster triggered by encounters with these denizens of the deep. For at least a decade after these initial 1980 publications, the scientific community of the time, thoroughly beholden to the doctrine of uniformitarianism, fiercely resisted this potential breach of the gradualist edifice that has dominated thinking about Earth history for at least a century. Where is the smoking gun? The critics demanded to know. Without a crater, we will not accept this thesis of cosmic catastrophe. That became their default position. Well, the crater was discovered in the early 1990s, hiding under the Yucatan Peninsula through the work of geophysicists Glenn Penfield, Alan Hildebrand, and Antonio Carmoga, forcing a lot of scientists, especially geologists and paleontologists, to rethink their opinions on the matter. In the ensuing roughly 40 years, there have been hundreds of close calls and incursions into near-Earth space by a variety of cosmic objects. Some of these close encounters have been dangerously close, either in space or in timing or both. And I will stop there, but that's a blog post I'm writing right now about the situation, and I'm going to be looking at some of these potential close encounters that we've had in the last few decades.
Or even a couple of weeks, I'm thinking. Like there's
Oh, yeah.
going on in the last few weeks. There was even one over Calgary where Darren is, and I mean, that's the shotgun blast it looked like to me, where it was breaking up into a whole bunch of pieces. But some of them that I've been seeing online are doing, it looks like 90-degree turns and stuff. It's getting a little sketchy.
Yeah, 90-degree turns. Well, but they can do that. See, the thing is that, it's one thing if you have a perfectly spherical object coming in as composed to some distorted object, that might have say the shape of a potato.
Yeah, and by the time it gets down low enough, it's going to be changing shapes the whole way through, becoming as spherical as possible or whatever.
That's right. And it's going to also be deflected, right? Because it's passing through the atmosphere is far more frictional than if it was like a perfectly smooth sphere. Right, perfectly round, exactly.
That's fascinating.
It is, isn't it? So back to the Finger Lakes, I think that what we're doing, I think we can say confidently that landscape, those landforms were sculpted by catastrophic water flows. Were there a cause of those catastrophic water flows a bolide impact? Well, I can't say for sure. We don't have proof. However, we have some microscopic evidence, like in the case of St. Jean, that would certainly tie the fallout from an impact event but not an impact event into Ontario, but an impact that would have literally excavated a hole in the ice and created the basin that's now occupied by Lake St. Jean. And if you go over and you look at
that Lake St. Jean impact and you line it up with the Lake Ontario impact, does that start making a line towards where our impacts are out west? Like, do you think this was sort of just like a barrage of this thing that sort of hit all of Canada at once?
I think that that's the first scenario I would explore as the scenario that seems to fit the greatest amount of evidence, which is that you had a clustered bombardment of anywhere from half a dozen to a dozen major pieces of a fragmented object, along with probably dozens and dozens of much smaller pieces. But the main pieces then would have, I think, left very telltale signs at their points of impact. Now, here's the thing. We're talking about an event that, if it was a multi-impact event, if it's a multi-impact event, we could potentially have impacts into the ice sheet, of course, impacts into a non-glaciated area, and impacts into the ocean. How do we differentiate between those effects? This is where it gets really sticky, and it's going to take a lot of research to sort this out, because we probably had all three.
But it would have been one hemisphere at a time.
Yes.
Now, because it's going to be coming from, say, that direction. So those like drumlins in West Africa would be a different event than what's happening.
Well, hold on. Here's the thing. You might have a stream that's a cluster could be 1 million miles long. So the Earth is passing through it. If it doesn't pass completely through the stream within 12 hours, you see, you're going to get a full hemispheric exposure to the incoming bolides. See,
and it's so big that it's the upper and lower hemispheres don't matter.
Probably not. Now, what's interesting is if we look at the pattern of extinctions, and I think extinctions, loss of species, can be a yardstick, because loss of species is going to be directly a function of loss of habitat, right? You lose habitat. Now, obviously, in a bolide impact, you're going to have mass immediate extinction within a certain limit, and that's what your program will calculate. You know, the overpressures, like how quickly did those overpressures drop in the distance from the impact and so on. But the point is, you're going to have fatalities that fall into two categories. You're going to have the instantaneous fatalities, then you're going to have the aftermath, which could actually be months afterwards, right? Because if you destroy the food chain and it hasn't
a year, it could be a year if you collapse the crops, you don't notice till the
yes, and if you've got atmospheric injection of a lot of dust and soot, and that basically wipes out the whole growing season. So in the aftermath of an event like that, you know, now you got famine and starvation. Now, if it's in an ocean, now see, here's the thing: you're going to find there's been a steady rise in modeling and studies of what happens when a bolide hits the ocean, which to me can help us to understand what happens when a bolide hits an ice sheet. Now, there's going to be differences, obviously, right?
Would it be like halfway in between, something like that, or?
Yeah. See, well, in the case
turning the ice into water, so there's that sort of thing happen at the same time, as if it can do it fast enough before it actually.
Oh yeah, I mean, again, the size and the velocity is going to determine the kinds of. I mean, we're talking about temperatures that could be 3,000 and 4,000 degrees centigrade. So you're going to have instantly conversion of ice directly into vapor, and that vapor is going to be shot out in all directions under high pressure. And it'll probably begin to circulate, and it'll take weeks for all of that water vapor to rain out. Then outside that, whatever point that the temperature drops down to where it's hot enough to melt, which it's melt the ice, but not to vaporize the water, you're going to have the production of meltwater. And then finally, you're going to have, just like if a bolide into bedrock fractures the bedrock, and you can look at radial shatter, ground shatter patterns, like at where bolides have struck bedrock. Just like throwing a rock at your windshield. Some kid throws a rock at your windshield while you're in shopping at Walmart, and you come out and you see that on your window. You're going to look and you're going to be able to pinpoint exactly where the rock hit the windshield, aren't you? But then radial pattern from that will be the fracture lines. And the bigger the rock, the faster the rock, the bigger the damaged area is going to be. Same thing with a bolide impact. But now a bolide impact into ice, what's it going to do? Well, at some distance, once it's cooled off enough that it's not vaporizing anymore and it's not melting anymore, you're almost going to have seismic shocks passing through the ice that would fracture the ice for, who knows, tens, maybe even 100 or a couple of 100 miles out from the impact site, see? Now, what that's going to do is it's going to allow immediate and instantaneous ingress of all that meltwater immediately to the bottom of the ice sheet. And I think that is where the subglacial floods originate that are creating the drumlin swarms.
Would there have been, because is there subglacial flooding? Is there any sort of subglacial flood channels without impact? Like,
yeah, because it has to melt it. As soon as it starts melting from whatever, it's going to start underneath, right?
Yeah,
that's right.
You have thermal spots that would maybe heat the ground enough. But if you have a mile of ice on something, and I just can't see how it ends up liquid water without an impact, without something.
Because it's slowly. I mean, if it's
like, is it melting from the bottom up?
Yeah.
Or the top
Okay.
down?
We have an analog that can give us insight, because the planets started coming out of the Little Ice Age between about 1800 and 1850. During the Little Ice Age, ice glaciers around the world swelled to the largest they had been since the end of the Great Ice Age, right? You would have to go back 10,000 years to where the glaciers were about the size that they swelled to during the Little Ice Age. So you had two phases of the Little Ice Age, 1314 to 1500s, then you had a little break, and then the 1800s, and then it came to an end. So if I had been ready for this, like, I could show you aerial photographs where you can see mountain glaciers receded well up the valley, and then at the bottom of the valley, you see very clearly the moraine. And that was the Little Ice Age moraine. And the Little Ice Age came on the heels of the medieval warming period. And during the medieval warming period, the glaciers shrank back at least as far as they are now, right? Then, with this rapid return to cold in the 1300s, the glaciers began growing. Okay, so now when they begin melting again in the 1800s and late 1800s, we begin to see what happened when, like, subglacial streams coming out from the snout of a glacier, for example, got much more vigorous as the ice is receding. That would make sense. When the ice is expanding, there's less ice melting. There's less meltwater. When the ice is receding, there's more meltwater, right? So we can see that there is an increase in melting. Now, when you have, let's say, trunk valleys coming into a main river valley, and that river valley is choked with ice. There we go. Perfect. Good look at that. Okay, yeah, now see that glacier has that's in the Swiss Alps. So you see the outwash plain down here, and right where it says 1989 moraine. So there is the moraine and in fact, look it up here, Little Ice Age maximum. So you see this up here? This is lateral moraine that's flanked up against this hill right here, this mountain. So
just going up to the Laya maximum, sort of?
That's the Little Ice Age.
Little Ice Age maximum.
Yep. So you can see that's how thick the ice was, like in 1800, right? And it started melting back. So as it melted back, it created much more vigorous meltwater streams. Now imagine that this glacier is melting back, and it's a tributary valley. In the main valley, there's still a big old glacier that might be 3 times or 4 times as massive as this valley glacier, right? What happens is the valley glacier is receding the fastest. It converts to meltwater, and that meltwater forms a pool or a lake, and the dam of that lake is the bigger glacier. Well, at some point, there's a threshold that's crossed. The volume of meltwater gets great enough. The glacier gets small enough that now it can no longer withstand the pressure of that rising reservoir of meltwater. The meltwater breaks through and floods and creates a catastrophic flood in Iceland called a Jökulá. Now, those catastrophic floods, of course, are minuscule compared to the floods that we've been seeing out in the Scablands, but it's just a matter of scale.
Yeah.
So what I'm getting at then is what we see with those glaciers as they're receding, as they're disappearing, as they're melting, the margin is moving backwards. See, you can see it. You know, you go up 1 year and then you go back a few years later, the margin's moved up and moved up and moved up. When we look at the Laurentide, the big ice sheet, or the Cordilleran at the end of the last ice age, it's not really behaving like that. In fact, what we see is that it looks like, rather than just marginal recession, which there was, but there was also what appears to be point centers of melting. And how do we do that? How do we determine those points? As we study the landscape under the what have been under the glaciers. Drumlins, I think, are the key, right?
Yeah. Is that so are we going to see some of that at Finger Lakes if we get back to like our trip coming up? We're going to tour around. We'll be visiting one of the most magnificent drumlin swarms on Earth. Nice.
And we might go and climb hill. You know, now I'm not a Mormon, but I'm very interested in the original visions that led to Mormonism. There's some interesting stuff there that kind of parallels a lot of the stories about Marinette, visions and encounters with angelic beings or all of this. So I don't discount that. But, I've been up there to Joseph Smith's birthplace, and there were 3 locations of the apparition of Moroni, the angel. I think it was Moroni, all 3 of them, according to the count. And where he was supposedly given the golden tablets was, if memory serves me properly, it was on the top of Mount Cumorah, Hill Cumorah, which is a drumlin. And you can go climb the drumlin, and it gives you kind of a good overview. You're still at ground level. So I guess we're going to need to take everybody up in airplanes. Is that included in the cost of a ticket?
That'll be extra.
Aerial overflights?
Aerial overflights are extra, but it wouldn't be the first time somebody lined it up on a trip. I mean, Timmy's coming to New York, I think, so he might book a plane.
Timmy Bush?
Golden tablets and visions are extra as well. I mean that kind of. I had an odd question. I mean, I don't even know if I should ask it. I'm pretty sure we must have asked you this before, but did you know Hunter Biden has the Finger Lakes tattooed on his back? Did you know that?
No, I didn't know that.
Yes, I was wondering if there's any occult significance or something of like. I thought you might know that of why he's got the.
Well, where's he from originally?
Oh, that's a good question. Okay,
I would guess maybe his family vacation there when he was a kid.
That's what I was kind of.
That would be my first.
It's nothing like more occult or secret than that, right?
Well, I got a thing to run by you here, Randall. I got it open. We don't really talk about this so much because we're usually focused on the Americas. But when you start looking over here at Saudi Arabia and Israel, you've got like over here coming through Riyadh, which looks like clear washing. That looks water caused. You've got this whole area down here by the United Arab Emirates that looks the same way. And then you have all this wash through North Africa that seems to come out this way. Past Malaysia out into the Atlantic Ocean.
Right. Well, I think that's the imprint of a extremely intense pluvial period over North Africa and the Middle East. And there's pretty good multiple independent lines of evidence that all point to the same thing, that there have been times when there was extreme rainfall and flooding over Africa.
Yeah, you're right, Randall. They did supposedly they vacationed near there.
Uh-huh.
Yeah, Cayuga County, Owasco Lake.
Uh-huh. Yeah. Okay. That's exactly what I would have guessed. But
Where do you want to zoom in?
yeah, zoom in, go there on Yemen.
Yemen.
Scroll around to Yemen, which is right there. Yeah. Now, zoom in and pan down a bit.
Are these mountains?
Yes.
Oh, so it does really look like it's coming down out of those mountains, eh?
Well, now pan up. I want to get you to keep going up. Pan to the east. Okay, keep going. And now zoom in.
Oh, wow.
Uh-huh.
So those are all drumlins.
No,
Are they not? Or those aren't drumlins? Those are something else, right? Chevrons?
no, they're current ripples.
Current ripples.
Now, are they created by wind or sand? Well, I think they're both. I'm sorry, wind or sand, wind or water.
Wind or water.
I think they were originally sculpted by water, and now the desert sand is regularly blowing over them. You know, the wind is now, but originally, and then go up to the upper right, that upper corner, and look at the changing direction.
Right here?
Yeah, look at that. Zoom in on that now. Yeah. Now you've got what looks like the formation of chevrons. Zoom in right there.
Right here?
Yeah, zoom in right there where you're at. Okay, now pan to the right. Keep going. All right, so here we're getting to the chevron life. Keep going, and you'll see that they're kind of forming, almost chevron-like. So then zoom out, and you can trace those ripples right on up over. There we go. Look it up here.
Oh, yeah.
Yep.
Into the Mediterranean. No, that's the Persian Gulf.
Persian Gulf. Yep. And I might, this of course is outrageous speculation, but I might speculate that was the waters that that spawned the legend of Noah's flood. And that you had a huge tsunami train that came up from the Indian Ocean, and then it got focused. So it got focused
into here?
Yes.
And into here.
Yes. And it probably washed up through the Rift Valley and then washed up, and if you zoom in up there by Q8. Now pan down. Now, I don't know if you're reading, I think you're reading elevation above sea level down on your lower right. Yeah, you're at 559 meters.
Yep.
Okay, so you might have had a tsunami that could have easily been hundreds of feet high, sweeping over this if you had a bolide impact into the Indian Ocean. And that's
if you
probably
look at it this way, it's sort of all heading into Egypt too, which could explain why a bunch of that shit is buried.
Yeah. Yeah. Well, there's a lot to be unpacked in this region, for sure.
Because then that wave would be sort of coming this way, right? Out of the bottom here?
Yes, and go down to Madagascar. Okay, now zoom in on the southwest of Madagascar. Okay, keep going. Now pan over.
Which way?
Pan over to the right. Sorry. Pan over to the... No, the other... I'm sorry. Pan east. There we go. Okay, keep going. Keep going. Okay, let's see. Stop. Zoom in. Go down along the coastline. Along there at about... Yeah, okay, now go over to the coastline to the west. Go to the west.
West.
West. Okay, now zoom in right there.
Whoa, look at those. These things? Is that what
Yeah.
we're looking at?
Okay, yeah. That's tsunami waves, deposits that have washed ashore. And if you pan to the northeast, you'll see that white-colored sand. Now zoom in on that. Okay, that is tsunami overwash right there.
That's 94 meters above sea level.
Okay, so that tells you that the wave was up there, that level. Now, do you see this dark line that goes northwest to southeast? That's an escarpment. Yeah, follow that up. Keep going there. Yeah, you're following that right. That whole thing is an escarpment. Now hover over the top of that and tell me the elevation above sea level.
157 on the high side.
157 meters.
150, 160 meters.
Okay.
Oh, it's actually the opposite of
Or
the
do you
way.
want down inside that escarpment?
I want both. So go up a little bit back from the upside of the escarpment, which is the northeast.
This way?
Just stop right there. Now zoom in, and now, okay, so now what I want you to do is pan to the west. Okay, now, okay, so you see those lobes there?
These ones?
Each one of those lobes represents like a successive wave train coming in. So you've got the furthest one up will be the first wave that arrives. It'll flow back out, and then it'll be followed by a second wave coming up that won't have quite the energy, so it won't move as far inland. Now, yeah, look at this. So look at this. Here you can see some amazing chevrons. And here's what's incredible. If you go back down to the escarpment, go back down. Okay, keep going down a little bit further to the. Okay, so right in there. Okay, so now hover over the lower side of the escarpment and tell me what the.
The lower side's around 145 meters.
Okay, 145. Let me get that. And then go to the upper side.
175.
Once it should be
175, 180.
180. Keep going a little further away from the escarpment. What do you get there?
187, 188.
Okay.
So it's getting higher as we go that way.
Right.
Like.
Now what I want to do is come back up, follow that escarpment up, because this escarpment is key. You'll see that what happens is two things. Zoom out now, and you will see that some of this deposits is on the lower side of the escarpment, and some of it is on the upper side of it.
Yeah, down here is 40 meters, and over here is 193. So 50 meters, so what, 150 feet higher?
Yeah, so at this point, the wave had to be high enough that it washed right over the top of the escarpment. And in fact, if you pull out and you go right up to the tippy top, right up there of the chevron, what's your elevation?
121 there.
So it went downhill a little? Was that?
Yeah.
What?
And then it looks like there's a hill there back here. The highest point here looks like it's almost 200 right around here. 197 meters here.
So yeah, call it 200. And then at the lower side, like go up to the left up there where you've got that real clear. Now go down a little bit a ways from the escarpment and tell me what is it right in there?
105 meters.
105. And the other one, so you're getting close to 100 meters difference.
Almost 100 meters difference, yeah.
So that wave had to be big enough that it overtopped this escarpment here. And it was already, we said it was what? What was it, the elevation, the lower one?
It's already 100 meters above sea level, 120. So 400 feet above sea level already.
Got it. See, now we're getting a sense of the scale of this wave that washed ashore here. Now, based on these these deposits,
those chevrons too.
Yes, these deposits can give us the source direction of the wave.
Yeah, it would have had to have been down here somewhere.
You look at the back azimuth, it's called the back azimuth, and it's down there. And in fact, that's what Dallas Abbott did and her colleagues. And they went to the point, and there is a crater on the floor of the Indian Ocean called Burkle Crater. It's 2 miles down. I forget the diameter of it, but it's pretty big. So it's right down. You've kind of gone past it. Go back, put your cursor down a little further, It's right in there somewhere.
Look at
Very,
that.
yeah, look at that. Close to the mid-Atlantic ridge.
Mid-Pacific Ridge? No.
No, I'm sorry. That's not the mid. What am I talking about? Boy, I'm in ozone.
That's a different ridge.
That's a completely different ridge. Boy, I feel dumb now.
That's okay. But you can see those are perfectly in line with that.
Correct.
And
now,
I would bet
imagine,
that Africa is almost, you can see where it came in over here and then came in here.
Yep. And you can picture the sea wave, the tsunami is coming north, and where you see the land kind of is a V shape, right? The ocean basin is V shaped there. So what that's going to do is it's going to cause two things. Is that not only is the wave going to increase in height as the depth shallows, but as the constriction, the confines of the coastline narrow, it's also, so by the time it makes landfall up there around the Straits of Hormuz and Yemen and Qatar, that wave is probably 1,000 feet high.
And you can see where it's all washed back out on this side too.
Mm-hmm.
Crazy. Well, we're not going there anytime soon.
No. Yeah, there's the town of Watkins Glen. Okay, good. Is this Google Maps or Google Earth? This is Google
Earth.
Okay, let's see. There's all kinds of stuff we're going to be looking at down there, but let's see. Let's see what Rainbow Falls. Click on that, and it should bring up a picture. Down there, yeah. Let's look at some of these erosion patterns. So go. Yeah, there, that's a good one. Zoom in on that now. Enlarge it if you can. Go full screen with that. I mean, you can begin to see how enchanting this place is and why Native Americans, I think it was the Iroquois who inhabited this region, told early settlers that there were little people that lived in these grottos.
It won't let me zoom in any more than that.
Oh, okay. Well, all right.
Well, look at that's a good one, though.
That's a good one, yeah.
So the Finger Lakes would basically be that, but on a giant scale.
Pretty much, yeah.
Are they deep?
Let's see what I've got. Yes, they are. In fact, they're much deeper than they're way lower than sea level. But they are filled with massive amounts of sediment, which shouldn't be surprising. So now, what's interesting about this picture, Graham?
Sediment.
Erosional patterns?
Well, yes. Let's get a little more specific than that.
The little mini pothole in the bottom?
Yes. No, it's not so little.
Wow.
I mean, it's 7 or 8 feet in diameter.
Yeah, okay.
And it's fairly deep. And it was not created by the modern creek.
Right.
That's the point you're looking at right there. Look at the next one. Here, this is...
I better be on my toes here. I didn't know this was going to be quiz. Oh, yeah, there's another. Wow, look at that.
Yeah. So this whole grotto topography down here is all sculpted by these catastrophic flows. And clearly, when you have potholes like this, you know that this is water that's deep and turbulent enough that it's creating vortices, powerful vortices.
So don't go swimming there, probably.
Well, now you can.
Now you can, but
yeah, you wouldn't have wanted. Yeah.
Is this the same idea as what we see at Palouse Falls?
Yes, exactly. You got it. You're learning the language, man. Yeah, look at this. Is Darren seeing this?
Look at that.
Yeah.
And it's also the drumlins, too. Check this out. Rochester Basin. How curious that all of this stuff converges on the deepest part of this basin that has all of this weird erosion on the bottom of it.
Does it look like that thing was coming from, like, that basin is kind of scoured out? Does that mean it was maybe coming from the southwest there and into that? Like,
You know,
It's not a total crater. It's sort of scoured, you know? It's
right.
like,
Well, remember, this was a couple of 1,000 feet of ice over this.
yeah.
And so what's going to put the final etching onto this landscape is going to be the water flowing, right? Because, you know, you can bring in if a bolide came in and struck here and it exploded, well, generally when it explodes, just like most craters are round, even though the projectile comes in at, say, 45 degrees, like you used. And that's typically in the modeling of impact events, is to just use the default of 45 degrees. But the explosion creates a round hole, basically a round crater. Now, if you get down to, I think, less than 30 degrees, you start getting ellipticity to the impact crater. So that could be.
Is that why the Carolina stuff, I forget what they're called now, that what's his name? We had him on the show. There's all those Carolina holes in them, but those ones are all elongated. So is that why we know they're ejecta and not impacts?
Well, I don't. You had
Carolina
Tony
Bays. What is it? The Carolina Bays?
Yeah, you had Zamora, Tony Zamora. Is that who you interviewed?
Who do we have on? The Dabbler's Den guy, right?
Davis.
No.
You had Davis.
No.
Who'd you have?
I think it was
Yeah, thank you. Yeah.
Chris Cottrell. Chris Cottrell.
Oh, Chris Cattell, of course. Yeah. All right.
But I noticed in all of his on all of his pictures, none of them are perfect circles like we see in the
No. They're all elliptical.
elongated. So that's because they're ejectica. They're moving fairly slow compared to.
Yeah, and I haven't fully accepted the ejecta hypothesis.
So you think those?
In other words, the idea there's up there near Saginaw, Michigan, is it?
Yeah,
Saginaw Basin.
Impact there. Yeah, and those were ejecta from it.
The ejecta was ice blocks.
Yeah.
That's Tony's Zamora's idea, and I don't know. I initially thought that they were, because if you've got what you have when you have a projectile like Tunguska coming in at a high rate of velocity like that, it creates a conical shock front, and when that cone intersects a plane, the cross section of that shock cone is elliptical. So if you have unconsolidated material, not hard bedrock, but sandy coastal plain type material, that shock front comes in at an angle, and the lower the angle, the greater the ellipticity. And we know that, low angle impacts can produce elliptical craters. Now, if it's a more Tunguska-like object, where it's an atmospheric detonation, there is a compressed shock front, and it's basically conical along the longitudinal axis of the cone. And when that hits the ground, right, it's like a higher, almost like, if you've got high pressure and you just blast, let's say nice smooth sand, and then you just hit it with a blast of high pressure air, and it creates a blowout hole. The blowout hole will be elongated and a parallel to the flow of the air that created it.
Oh, so an airburst is more likely to make an elliptical.
That's what I would think. But I don't know. I don't have any final. Although, it was my studies of the Carolina Bays that ultimately led us to the Scablands. And that's a whole other story in itself. But I was figuring that, okay, if you go by the orientation of the bays in North and South Carolina, they're pretty much oriented southeast to northwest, about 45 degrees. So if you follow that trajectory, I wasn't looking at the basin in Michigan there. I was imagining a bolide coming in, breaking up over the ice sheet. This is about mid to late 1980s, and I'm looking at this, and I had a map, and I actually took and drew on the map, well, where would a hypothetical trajectory be of this incoming bolide that created the Carolina Bays? Okay, it would have come right over the ice sheet. Well, let's see, was there anything unusual that was been documented with respect to the ice sheet? And then I remembered that I had read a book in 1980 where the author, Cedric Leonard, had a chapter called The Catastrophe of 10,000 BC. And one of the things he talked about in there was the great flooding of the Channeled Scabland. And that was the first time I knew about the Scablands, 1980 or 79, when I read Cedric Leonard's book. But at that point, I go, oh, well, there was this evidence of these big floods up in the Pacific Northwest. Could that have had any connection with some kind of a celestial impact? So that idea kind of got my craw around 1988, 1989, right in there. And it wasn't until a decade later that Bradley and I were actually able to go out there and explore the Scablands for the first time. But in that interim, that next 10 years, I studied deeply into the Scabland. I read all of Bretz's papers. I read J.T. Pardee's papers on Lake Missoula, and, a bunch of other stuff. Richard Waite's paper where he's theorizing multiple floods. Vic Baker's paper where he, in 1973, where he calculated the hydraulics of the peak discharges and realized they were even bigger by far than Bretz was speculating. But yeah, so then 1998, Bradley and I went out there and with a couple of buddies of ours and been back to how many, I've lost count, how many times now we've
5 or 6 just with us.
just with you guys.
We're doing that Chelan trip with the Sacred Geometry a couple days in it, but we're also going to Dry Falls for that. I mean, in a lot of ways, Dry Falls is sort of the crown jewel of all
It
that.
is.
It's the
It
one
is.
thing you can look at. Water made it. There's no fucking water anywhere near there. Everything else sort of still has some water around, or a creek or a river that they can say, oh, well, that came from when that river was bigger or this or that. But you go to Dry Falls, you're in the
Right.
middle of fucking the desert, and there's this giant cataract there. Not cataract, but
Well, yeah, a cataract. It's a dry cataract, but yeah, it's a cataract and many times bigger than Niagara Falls.
so
I
that
mean-
must have been, what was it like seeing that the first time?
Seeing that it was mind-boggling because I had been visualizing all of this stuff in my head for over 10 years. Picturing Dry Falls, read the papers on it, all of that, looking at photographs. And of course, at that point, there was no internet, so I wasn't able to quickly go online, but I spent a lot of time in the libraries. I was able to go back and get Bretz's original papers going back to the 1920s and the photographs they had in there, Pardee's original papers. So yeah, I'd had this stuff in my mind for 10 years. So when I finally got out there and I'm seeing it for the first time, it's like, oh, wow. I mean, I was like a kid, because I can remember how excited I was when I was 8 years old and I was going to go see Journey to the Center of the Earth.
Now all the visitor center people know you.
Yeah. So I brought a lot of people out there, hundreds that, and a very cool community of people that are, made our tours part of their lifestyle. And
That's probably the best part of the tours is
I know.
this community that I mean, the tagline is where community becomes connection, and it sounds kind of corny, but we sort of got that weird thing that almost borders on a cult where everyone gets along so well that they come to the other tour and the other tour, so there ends up being repeats and people end up becoming best friends and staying in touch. And
I mean, like some of the Telegram groups from Scablands still going. The Azores Telegram group is going strong. Yeah, that to me is really of course, I'm just so immersed into the geological story because to me it's so compelling, and it's a story really whose time has come. It needs to be told. People need to know this stuff because ever since the advent of global warming, we're not supposed to look at natural events like this. Everything is our fault now, see?
Yeah.
So if anything bad happens, it's us.
Yeah.
But, if you are studying the kinds of things we study, you go, okay, let's see. There have been extreme climate changes. There have been giant catastrophes. There have been forest fires. There have been huge floods, all of which we were the victims of, not the perpetrators of.
Yep.
So
Exactly.
here's some LiDAR stuff from, this is at the south end of Cayuga. And what this shows you here is how the valley are, it's just, you could take this water out, drain this water out, and you'd have this deep gash in the earth. And then this is all sediment. You could probably scoop this sediment out and you'd have still hundreds of feet deep. But this is how much water has filled it. But this is just the extension of the trough occupied by Lake Cayuga. And let's see, and then I've got Lake Nipigon here. This is interesting. We're not going to get up to Nipigon, but, we've talked about that. And we maybe look at that for 2027, maybe. But, yeah, I think that Nipigon is a prime candidate for an impact site. And here you can see.
Tough to get into Canada by 2027, the way things are going.
Oh, God. Yeah, here you see Lake Nipigon, and then there was a catastrophic outflow to the south.
Into Superior.
Yeah, into Superior. And look at this whale tail of delta sediment that's been washed out.
Is that the Sleeping Giant right there? So that must be almost by Thunder Bay.
It is by, yeah.
Yeah.
Let's see, do I have a picture of let's see, I may have a picture here. The Sleeping Giant is down here by Ruby Lake Park.
Might be that one right there in the middle.
This one, or which one?
That one your pointer was just on. Yeah, it might be that one.
This one?
Yeah, that one or the one right next to it.
Well, let's see.
I forget which one it is now to even look at, because it really doesn't look that much like a giant. I mean, I remember being a kid and being supremely underwhelmed when
there we go.
They're like, we're going to see the Sleeping Giant, and I was super stoked. And then I was like, really?
Well, I don't know. If I get up there, I haven't been. I was up here as a kid. Actually, my dad drove us up there when I was probably 8, 9 years old. And I remember there was at one point, and I think it was the going back here. Let's see if I go back to this. Yeah, here you go. This is black sturgeon right here, which is very much like Moses Coulee. It's a little bit smaller, but it's basically a catastrophic flood trough that came down here. And I remember, I'm pretty sure we went to the rim of that. And I remember getting vertigo, standing there looking into it. But I was just a little kid. This might be, is that the Sleeping Giant right there?
Could be. It's on like a pull-off off the road. It's not far from the Terry Fox thing.
Okay. So these are showing routes of meltwater. So there's a Sleeping Giant. There you go, Sleeping Giant.
Yeah.
I don't know. I kind of see a Sleeping Giant there, don't you, Graham?
Yeah, it's a little more obvious from that angle. Yeah.
So Darren wasn't impressed, huh?
No.
Well, I was expecting a giant. I was a little kid. I was expecting
I see. Well, now maybe next summer we go back to that and you'll be impressed.
Maybe. Yeah, we could. I mean, it's beautiful country.
Yeah, look at it. So here's the Sleeping Giant. Now, see, look, Darren, you don't know. I mean, the giant fell asleep, and then he got covered in debris and forests and stuff. And one day he'll wake up, and then he'll stand up and stretch and yawn, and then you'll realize.
Well, I'll withhold judgment until then.
And they have some magnificent slot canyons. This is definitely evidence of catastrophic drainage from Lake Nipigon right here.
Wow.
Look at this.
That water at the bottom of that still? Is it still a river down there?
Probably.
Or is it dry?
Well, there'll probably be, I'm sure there's a creek at the bottom. So, yeah, let's see. There's Ruby Lake. Looking south, Ruby Lake occupies an elongated basin scoured by highly erosive floodwaters. Ruby Lake Overlook.
I mean, the thing about up there is almost everything looks like that, and you don't realize at the time that it's because all the stuff in between has been removed.
Correct. And here you've got basalt. This is not unlike some of the stuff we see in the Scablands, columnar basalt.
It even has the washout at the bottom of it.
Even has the Yep. Good observation there, Darren. Yep. Then you have a lot of these kinds of things.
I think the main problem we were looking at with the Nipigon trip is there's just no place to, there's no infrastructure.
Yeah. Now, how's this for a pothole?
Devil's Crater.
And then here's your, here's the pothole and here's the outwash channel. And, yeah, you can look at here's the pothole and you can see the whole outwash channel this way.
Yeah, if you took the trees off of that, it'd be really apparent. You can almost sort of see through them a little bit.
Yeah, yeah. And then here, like you said, here's the wash-up stuff here. And look at the canoe down here. That gives you a sense of the scale. Looking at this canoe down here. So the lake is about 220 feet deep, and the crater walls are about 220 feet high, making the full depth of the pothole about 440 feet. With a width of about 660 feet, this has to be one of the supreme examples of vortical cavitation on Earth. So there's your black sturgeon spillway. And here you can see black sturgeon spillway on top, Moses Coulee on the bottom.
Oh, yeah, look at that.
Yeah, scaled to the same size. So,
Moses, about half the size, it looks like.
Right. So you probably had about 100 million cubic feet per second coming through here.
Oh, there's a little bridge there. You see that? And the stairs coming down the left side?
Yeah, I mean, it's amazing how these catastrophic currents can just sculpt that out so perfectly.
Man, I wonder how long that's been there for, though. I mean, the thing about getting over to New York and stuff is there's some real history there compared to
where
we've only been here for 50 years, or not quite that short, but you really start to notice that the West is a lot newer. You don't have any of this stuff that's hundreds and hundreds of years old.
Right. Let's see what else we got. I mean, you can get a sense that, I mean, when you're there, you really do get a sense of, yeah, I can see how somebody would think this place was enchanted.
Yeah, you'd never want to leave. Is that mostly state park around there? A lot of private property, a lot of rich people, I'm assuming.
Watkins Glen is a state park. And we're looking at Watkins Glen right here. These are the glens, just like you have glens in Ireland. Okay, here's one where you've got some major water flowing in the creek.
Man, look at the difference, eh? One's got I guess it's out there. It's probably more dependent on rain than melt. It just matters when it's raining.
Correct. Although, you get a lot of snowfall. So in the spring, you're going to have the spring melt that's going to augment the flows. Let's see what else we got here. Yeah. And here, look at this. Look at the sculpting. Here you can see the vorticular sculpting. Oh, yeah. I mean, it's an amazing place.
Look at that little slot back there with the water going through it. It really is something else.
Yeah.
Doesn't look real.
Well, yeah, and here, see, look at you can see the effects. So you had multiple vortices. So the water was well up over the top of the grotto here. And within that water, it's moving fast, swift, because you have to have a high degree of energy and shear forces being generated against the channel walls to create these vortex. I mean, these are literally almost like underwater tornadoes. That's how you have to visualize. So there would have been one right here. There was probably one up here. And then you get downstream, you can see this rounding. This is water vortex.
Are those pretty deep too?
Well, I've been in them 4, 5 to 6. Some of them were over my head. Some of them I could stand up in, like up to my chest, but it can also vary a lot, depending, like you said, on rainfall. If it's later in the summer, these things will shallow out a lot.
We'll be there right at the tail end of summer. So
I think when we're there is going to be a nice time of year to be there.
It should be. We'll have a busy fall because we're back to back. We got beginning of September and then beginning of October.
Yeah, I mean, it's really magical when you're in this place and the sun is filtering down through and you get these cool lighting effects and then the water. I mean, it really is. It's one of the most magical places I've ever been.
Is that the whole area? Or is that just Watkins Glen, or is the whole sort of?
Oh, this is just Watkins Glen. I mean, each of these big lakes has some of its own.
That feature the south end of each of the lakes?
Yeah, it's different. We can go over and we can look at some of the other places. Let's see.
This is Lower Falls at Enfield Glen.
Okay. So yeah, this is a different Glen than Watkins Glen.
Yeah, this was looks like it's about 10 miles south of Ithaca.
Okay.
I just followed that same channel down. You can sort of follow the channel down. You can sort of guess where the features are going to be when you can understand what the landscape's looking like.
Right. Yep.
But this one's got that same sort of idea through there with it's unbelievable, really. That looks like a popular one. But we're there during the week, so it shouldn't be so busy.
Yeah. Yeah. Actually, I went there. I don't remember if we swam, but I definitely went there. That was some of the native peoples there.
Yeah, I was able to get to that. I mean, really, I just went and followed this thing down. Then there's the Buttermilk Falls.
Yeah, go to that. Buttermilk is nice.
That's a nice slow cascading one.
Uh-huh.
There's another one of them pools you're talking about.
Yep.
Oh, look at that. That's
almost there. You got a pedestal rock.
Yeah, it's like Chimney Rock, a little mini one.
Exactly, and that's a very typical. Out west they're often called hoodoos, but they're a typical byproduct of catastrophic flood erosion.
I guess the big difference is that Chimney Rock is so fucking high up, and it still looks like that.
It still looks like that, right?
There's another pothole in a drainage, it looks like.
Yep.
So this is another spot I believe that was on the itinerary, so.
Buttermilk Falls?
Yeah.
Uh-huh, yeah.
Looks like it's something else. And then that was just at that lake. I mean, we start in, where's Buffalo? Where's the falls compared to this? That's sort of where we're starting from.
That is to the west.
Yeah. So we'll be coming from this side. See what this one looks like. Yeah, that one's kind of lame. It does seem like it's the south side of them that's compared to the north. The north looks a lot more, looks less catastrophic.
Yeah, the north end of the lake, yeah.
Yeah.
Because, see, what's happening there is that the water it's like, imagine this big surge and it's moving uphill as it comes into the Alleghenies. Then it has to reverse and flow back out. Part of the thing is on the north end, you're going to have a lot of outwash sediment that's going to tend to bury differential topography.
Yeah, you can really see it even on the depth of the lake, right? Both of these lakes get deeper and deeper the further south you come. That one doesn't quite have the same channeling effect as the other twos did. Those two big. Oh no, I'm not far enough over yet. That's why. Look at this.
Yeah. It was. I did a little research on that, and yeah, it is named after you, Darren.
It's named after me. How'd they know?
So I think we need to go to Grimes Glen then.
We're probably home of the oldest fossil tree found and mounted by D. Dana Luther. I don't really know what that means.
Oldest fossil tree found and mounted by D. Diana Luther, Naples, New York, now in the State Education Building in Albany. Well, we'll have to stop in there. You can go in and you'll tell them, I'm Darren Grimes, and I'm here to reclaim what is mine.
Wow, look at that one.
Yeah. That's Grimes Glen State Park. I think
that's my cave.
That is, your personal place of refuge in times of
my little hideout. Well, I hope some people do decide to join us. It's going to be a good trip. We do have a busy fall with 2 trips coming up. So, the Finger Lakes, though, we've never done that one yet. I've never even been to New York, so I'm pretty excited to get over to the east side.
Well, I don't blame you. It's a wonderful place. And let's see. So, you're standing on the ground and you're just looking at this hill. But, then if you go from the air, or above looking down, that's when you see that you got hundreds and hundreds of them. And they're all in this N echelon pattern. which tells you that the formation of them, this isn't just an isolated hill that's formed by some local something that happened here. It's part of this huge pattern that covers hundreds of square miles that has been shaped by these huge subglacial floods.
It actually looks like we're going to the Cornell education thing, the science center.
Yeah, I wanted to see that when I was there before, and I think it was closed when we were there. But that's cool. Let's see.
Then there's Fillmore Glen State Park, as I see on the itinerary as well. Watkins Glen State Park, the one we were just looking at.
Yep.
Letchworth State Park.
Yeah, check out Letchworth.
Letchworth?
Ooh, yeah, that's right. I remember that now. Did visit there.
This is Letchworth State Park. There's a ton of waterfalls. It looks like we'll see a ton of waterfalls.
Oh, yeah.
Oh, look at that big canyon, eh?
Yep.
And then you got this point coming off here. So is this where the water switched directions? Is this a fork?
There's a place right up on the southern shore of Lake Ontario, where the waters of the lake have eroded a drumlin. And let's see if I can remember.
That's a great picture there.
Yeah, look at that. There
must be springs up. Is there springs up there? Is that water all coming out of springs?
Well, it's probably being augmented by springs, no doubt, but I'm thinking it's mostly, runoff from the uplands, like, the Adirondacks. So this is along the southern shore of Lake Ontario, wherever the drumlins have been truncated by the water. At one point, the water level of Lake Ontario was much higher. In fact, it was probably right up over this embankment here completely. But yeah, so then the water receded and it left this behind. So if you were to look at this, you from above, you would see that this is actually phases or transitions into a drumlin. So this is like eroded section through the drumlin that would have originally extended on out into what would be the lake.
Are those all glacial melt then, those lakes? Are those leftovers from the ice sheet?
Yes. And this would have been glacial till. This is the stuff that I was talking about that is under the ice sheet. Let's see.
That must be the same idea. There's so much more water there compared to up in Manitoba, though. But Manitoba's got that same sort of idea. The interesting thing about the Manitoba lakes is you can walk into the things forever. You go out 100 feet, and it's still only 2 feet deep.
So, Chimney Bluffs State Park. And I don't know if this is on the itinerary, but we're going to be pretty close to here, and I personally wouldn't mind seeing it myself. Because again, this is the stuff. This is the raw material, the glacial till. And all of the drumlins, the hills, if you cut into them, they would be composed of this same type of material.
So you can see them here.
Oh, yeah.
You can really see what you're talking about there, where they're cut off here and here.
Yep.
So is that flowing back into the lake or out?
I think it flowed first to the southeast, and then it backwashed back towards the lake.
So then that one there would have been, that's dead center of the Finger Lakes.
Yeah.
Dead center of that, down in through the drumlin fields. I know we have a day of driving in around through those drumlin fields, so it seems like we could rip up there easy enough.
Mm-hmm. So that's massive, thick layers of glacial till that were sculpted into drumlins and then eroded by the water, which I'm guessing was probably the backwash into the lake.
That's even on it even seems like that's on another mound.
So
now you can probably really see those drumlins like that too, which should be right in here pretty well. It's hard to believe how far that stuff has come. It really is. That's fucking crazy that you can do that.
Yeah.
Well, all right, Randall, should we get out of here?
Let's get out of here. I got food that I need to be eating. But yeah, there's a lot to decipher here with this.
Yeah, it's going to be interesting. I mean, it's sort of like I've been to the Scablands so many times. I'm really looking forward to this one because it's going to be all new to me.
Well, and the thing is to keep in mind is we could just be looking at two regional manifestations of a much bigger event.
Of the same thing.
We need tighter dating of though. And even if it wasn't, I mean, clearly, if there was a phased meltdown of the ice sheets, which is what it appears, I mean, are we talking about there was a giant input of thermal energy out west that caused that melting, and then this was a different one? Or, we didn't get into the where I've been going with my research is by studying the subglacial topography, principally drumlins, using that to decipher where the impact events occurred, specifically where you had hits on the ice sheet.
Yeah, if they could get all that whole area with good LiDAR data, you could theoretically just line them all up and find a half a dozen or a dozen impact points across the ice sheet.
And I've done that. That's exactly what I've done.
So that's what's coming up soon?
Yeah. Yep.
Excellent. Well, we got a couple tours this fall. If people want to come, they can come see the Scablands side of things with us, or they can come and see the east side of things on this New York Finger Lakes, or they can do both. There's a chance to see both of them this year, both these sort of cataclysms,
and
maybe the same cataclysm.
Look at Lake Chelan. It's a Finger Lake.
Yeah, it's almost identical.
Mm-hmm. But it was actually occupied by a glacier. And the terminal mooring at the south end, which just overlooks the Columbia River, is the dam that's holding in the water. If you breach that dam of mooring at the southeast end of Lake Chelan, that water would mostly drain out.
I'm trying to find it here. That's Banks. Banks is the ground. Oh yeah, so here it is. I'll share my screen again quick.
Yeah, let's do that quick. What happened to Graham? Did we lose?
He had a hockey game. He's back to playing hockey. So I think.
Oh, okay.
Typical Canadian. Yeah. So here's Lake Chelan here. Now where we'll be staying is right down at this end, right on the lake. I don't know which one it is, but one of these is Campbell's Lakeside Resort.
Oh, I think that's where we stayed before. Yeah, that's really nice.
Yeah, we're staying there the whole time. So.
Okay.
And working out of there. And then, of course, so you've got this giant Finger Lake that we'll be checking out. I think the Okanagan Ripple Field that Brad was super impressed with is over here, right?
No.
Or is it over here?
Well, it's probably up by the Okanagan, which come to the east, stop. Okay, now zoom in. That's the Okanagan River there, and I think it's south of there. I'm not sure which one for sure he's talking about, but it could be right in there somewhere.
I know he said it was one of the most impressive things he's seen.
Oh, really?
Yeah, he was, because I looked at maybe cutting it from the itinerary, and he's like, man, when I stood there, it was crazy profound, and there's no way Randall can't stand there.
Yeah, okay, so that sold me on it.
Yeah, you can kind of see it spreading out from there, right?
Yeah.
And then, of course, we're not far from Dry Falls, so we're going to pop over there for the day, would Dry Falls be now?
Come down right in there. Yeah, zoom in there. Yeah, there we go.
So we're going to have the last day. We're going to come out here and finish off that trip with the Dry Falls, and we're going to do what we always do, which is, I wonder if we can click on this. This is probably almost off of that catwalk. So there's that little catwalk that goes out there, and you get your picture taken with Randall, and this is the backdrop. And I mean, we've been out there. You remember that time? There's that little catwalk there. That's from the catwalk looking in. But remember when we were out there and the jet plane came through?
Oh, yeah.
And there's an artist rendition. And it's fun to come to the Dry Falls with us because we'll go into the visitor center and there'll be a guy there that's supposed to give us the mainstream thing. But whenever he sees Randall, he just sort of shuts up. And last time I made you call him Dudley.
You did. It was because I was, yeah. So I'm going up there. I'm like 2 days, 3 days deprived of sleep. And then Darren comes walking by and says, "Oh, Dudley just whatever." So it said you couldn't fly your drone. Wasn't that it?
Yeah, I got in trouble for. There's the catwalk right there. While you get your
Yeah,
picture
Darren
taken.
got in trouble from Dave, the ranger there, and he comes by and he says, "Dudley wouldn't let me." And I walked in and he's giving a presentation to a group of people, and I say, Hey, Dudley." And he looked at me, and then I thought, why did he look at me like that? And then I realized, wait a minute, his name is not Dudley.
So here's the website, of course, contact@thecavern.com. There's Randall right there, world-class guides. There's Randall. I think that's Bruce holding the sign for you, right?
Looks like it. Yeah, he was kind of the designated sign holder.
Yep. And then here's you and Dave Matheson at Dry Falls.
Yeah.
And then this one has got to be, this is you again.
That's Steptoe Butte.
That's Steptoe Butte.
At sunset. Right? Yeah.
What a shot, eh?
I know.
I believe this is Chuck got that shot.
Yeah.
So if people scroll down, they got the tours right here. All of our tours: Serpent Mound, Easter Island, Sicily, Sardinia, Malta. Sardinia looks amazing.
When is that? 2020. I think I'm going to try to make that one.
If you want to come, you just let me know. I mean, I'll send you the itinerary. It's phenomenal.
Yeah, I believe it.
Sardinia, I was most excited because of the Hypogeum. But then, so we started out, I think it was like basically 4 days on each or something like that. And then we ended up taking a day off of Malta and a couple days off of Sicily because there's something like 200 sites on Sardinia or more.
Wow.
It's almost nonstop. And a lot of the Cyclopean stuff. It could be the single most impressive place I've seen from the megalith standpoint. But people can pop in here. Here's our New York Megafloods tour. We got a rough itinerary. 162 days until we go. And then we got the other one here, which is the Chelan one with Scablands, Sacred Geometry, and Rift Valleys, which is another one. So we've only that one there. We sold one ticket so far. It's only been on sale for a couple days. So, but can you? I'm wondering if you can guess who bought the first ticket.
Peter?
No, close. Keith.
Who would that have been?
Keith, the British fella.
Oh, Keith, right? Keith. Okay.
Yeah. So he's coming to that one, and then we've got a bunch of regulars already coming to the New York one. Ed and Renee are going to be there.
Awesome.
Alex is going to be there. Yeah, it's going to be a good time. I mean, this is sort of what happens is once you come to one, it's hard to not come back.
I know.
Really, which is probably why we're still doing it.
Undoubtedly.
All right, Randall, you want to go eat?
I do, and then probably hit the sack. It's getting on 11 o'clock here, isn't it? Well,
yeah, that sounds about right. It's getting dark here, so.
Yeah, okay. Well, all right, Darren, I'll talk to you soon.
Sounds good, brother. You have a good one. It's good chatting, and we'll catch up real soon.
You got it.
Okay.